Alright, welcome back. We've got our free response question today on Taylor series. So objectives are to create differentiable Taylor series approximations for a given function and then use them to estimate points of inflection. Before we do all that though, I want to quickly review all of our convergence and divergence tests since we'll be using one of those today. So we'll go through each one of these. I need you to give me a rule, and then based on that rule, will the test converge or diverge? So for instance, I've got Interim Test listed here. The Interim Test says, as long as our limit as the sequence does not approach infinity, then our infinite series of that sequence will diverge. So for a p-series test, what would my rule be?
Series, it's 1 over n, and then if the, no, yeah, 1 over n to the fifth power, and then if p is greater than 1, then it converges.
Okay. If p is greater than 1, then we will converge. Looks perfect. Okay, how about our geometric series?
It's a times r, and then if r is between -1 and 1, then it converges.
Okay, if r you said is between -1 and 1, so the absolute value of r is less than 1. And if that's true, we'll converge. We can be a little bit more specific. What will it converge to?
A over 1 minus r.
Perfect. So a lot of times, if there's more than one series test that'll work, we'll prefer geometric series because it gives us a little bit more information. We know what the sum will be if it does converge. Alternating series.
It's -1. There is -1 to the nth power of that.
Okay, so I'm going to say if our series is alternating, so we could rewrite it as -1 to the nth power times b raised to the n. And, okay, what would have to be true about b to the n?
If b to the n is less than bn plus 1, I think.
I think it's going to be the opposite of that. So if our next term is less than our previous terms, that means we're decreasing.
Yeah. Then it's converge.
Okay, I've got to be decreasing. There's one more thing that has to be true. Let me give myself a little bit more space here, but b to the n. So I'm just rewriting. You can keep going.
I forgot.
Okay, so my function has to be decreasing, and I need to pass the nth term test. So if my limit is n approaches infinity, yeah.
Limit n approaches infinity, an should be equal to, no, an should converge 0.
Okay, So as long as our limit of the whole function approaches 0 and we're decreasing for every term, then we will converge. Okay, how about direct comparison?
So we compare it with a simple one.
Okay, so I could say pick any other series you want. If we'll say R series if b to the n converges and 0 is less than a to the n is less than b to the n, then what should be true? So the series we picked converges, and the series we picked is always greater than the series we started with.
Then it converges.
Okay, then a to the n converges. Okay, I'm going to write another one for this. So that was if b to the n converges and okay, then also if b to the n diverges, and what else should I write here?
Then an is greater than bn.
Right. So 0 is less than b to the n is less than a to the n. Then what would be true?
Then it diverges.
Okay, then the original series diverges. Okay, all of those were what worked for if it was positive. However, the same idea will still work if it's negative. So if b to the n ends up converging and b to the n is more negative than a to the n, then a to the n will also converge. If b to the n diverges and b to the n is less negative than a to the n, then a to the n will have to diverge. Okay, limit comparison. So
It's kind of same to direct, but we put limit in front.
okay, so I'm going to pick b to the n. Then if the limit as n approaches infinity of a to the n divided by b to the n is equal to some constant c, such that c is greater than 0, then what would be true?
It converges.
Close.
Conditionally converge.
Closer. The convergence or divergence of a to the n and b to the n are the same. So if b to the n diverges, then a to the n will also diverge. If b to the n converges, then a to the n will also converge. convergence or divergence. For a to the n is the same as for b to the n. Okay, and then integral test. So there's some conditions for this one, but if f of x is continuous, positive, and decreasing, and the integral from n to infinity of f of x converges, then what has to be true?
It converge.
Right. The sum of a to the n converges. Okay, I'm going to go back and I'm going to erase this a to the n, so I just realized I've got it twice here. The sum from a to the n, a to the n. Okay, so the sum from a to the n converges, the sum a to the n diverges, but I did that right for all the other ones. Okay, then ratio test. If the limit as n approaches infinity of the absolute value of a to the n plus 1 over a to the n. So that's my next term divided by my previous term. Ends up being less than 1. Then what would be true?
It converge.
Okay, then this would converge. And then here in green, what would prove that it diverges?
Diverge. If it's greater than 0.
Not 0. If it's greater than 1, then it will diverge. And then what happens if it equals 1?
Also converge. No, inconclusive.
Inconclusive. Okay, so our ratio test doesn't actually tell us anything, so I'm not going to write it. But if this limit equals 1 exactly, the ratio test fails. Okay, the last one and the least common one. So I'm going to give you all of our conditions for this one, just because I don't think we've gone over any of the conditions really. The limit is n approaches infinity. Infinity of the nth root of a to the n ends up being less than 1. Then what should be true?
It converges to number.
Okay, then it will converge. Now there's a couple of these I did not write this for. But there's a handful of these that give us a little bit more information than just does it converge. So for this root test, we know that it converges absolutely. And for the ratio test, that also proves absolute convergence within our interval, where we were less than 1 for our fraction. However, for the ratio test and the root test, at the bounds of the interval, where this equals 1 will be inconclusive, and we'll still need to do another test. So I'm going to add one more line for the root test then, just to show that inconclusive part. So if the limit has and approaches infinity, just like the ratio test, of the nth root of a to the n ends up being less than 1, then I could say that this function diverges. Okay, for the alternating series test, how could I prove that the alternating series test converges conditionally?
Conditionally, so after we find the interval, if one part is if one part converge and the other part diverge, then it conditionally converge.
Okay, you said for the alternating series test, say it again, if one part converges but the other part diverges?
Conditionally converge.
Okay, that's not what I'm looking for. Let me give you an example. So if I took,
Like if limit n approaches 0 and then a n.
okay, so if I had the sum from n equals 1 to infinity of -1 raised to the nth power over n, then this would converge conditionally. Why? Versus, I'm going to write another one that converges absolutely. N equals 1 to infinity of -1 raised to the n power over n squared. Converges absolutely. Okay, why does the left one converge conditionally, but the right one converge absolutely?
I cannot see the number.
So the function is -1 raised to the n power over n to the p power. If p is 1, the function converges conditionally. If p is 2, the function converges absolutely. Can you tell me why?
Because if p is 1, then the piece it diverges due to p series.
Okay, so normally it would diverge. So what the... There's a condition. What's the condition?
If when we test other series, it diverges.
Okay. I'm going to take that as I think this is just an English problem, but what you're saying is not wrong. So if we take away the part of this function that alternates, and changing that would make our series diverge, then we can say that the alternating series converges conditionally. So if the only reason this is converging is because it's alternating, then it converges conditionally. But if this would converge even if it did not alternate, then it converges absolutely. So a function like this, if I take away the -1 to the n, so it's not alternating anymore, is just 1 over n and would diverge by the p-series test. So I could say the alternating series that we started with, negative 1 raised to the n power over n, converges conditionally because it only converges since we're alternating. But negative 1 to the n power times 1 over n squared would converge even if we took away the alternating series part. So we can say it converges absolutely, no matter what. Okay, I'm a little bit over time for where I want to be right now. And I think that's okay, because I kind of want to let you try the problem we would have done together on your own anyways. We've done one similar last week, so I don't think it's that big of a deal, and I kind of want to see how you'll do independently instead. So we've got 3 problems for you to try on your own this time around instead of just the normal 2 free response. So I'm expecting it'll take 45 minutes to an hour or so. That is problems 4, 5, 6 from the sheet that I sent on WeChat and Skype. And that will be due Wednesday at 9 a.m. I'm also going to send the chart that...
So I do 4, 5, 6?
Yep, 4, 5, 6 on the free response questions that I sent through WeChat and Skype. And then I'm also going to send you the chart that we just did. Actually, I'm going to screenshot. And you can use that if you want. Either to study or just to help you out on this assignment. I'll also send you the flow chart from Stewart's book. Just so you've got that in one place. So that was this one. Okay, and I'll quickly do that on Skype as well. And we'll be all set. Do you have any questions about anything coming up?
Oh, this one. No.
Okay. The end of the quarter for your progress reports is the end of this week. So I am still working on finishing up grades from this weekend. I'm a little bit behind. But those should go in at some point before 9 a.m. tomorrow. So I'll let you know tomorrow when we do our morning session, once all the grades are in. If you're missing any grades or anything. I don't believe I'm missing anything from you though for either class. So the only thing that could happen is if maybe you missed one of the free response questions from one of the days or something. But I have submissions from you for all of the stuff that I haven't graded yet, at least. But please check with the other teachers and make sure that you're okay. Check GradeLink, make sure that all of your grades are in. I know especially for the classes that I have that have a lot of students. Just getting everything through WeChat, it's really easy to miss something. If I'm not logged into the computer, then sometimes it sends to just my phone or just my computer or vice versa. So it's super easy to miss something. But if you just let us know, we can go back, check the phone, check the computer, and usually find whatever we missed.
So I didn't miss anything yet, right?
No. So right now I've got submissions downloaded for you from everything that I haven't graded yet as well. The only thing that I could be missing, because I haven't graded your last 2 submissions for either class, would be if you're missing a part of that submission instead of the whole. But I've got something submitted for every assignment that I have not graded yet.
Oh, I missed some.
Okay, so
Some.
I don't think you're missing any homework. I have a submission from you. I have files from you for every day so far. It's just whether or not you had all the free response questions that you were supposed to for those submissions. So I'll know by tomorrow morning after I finish grading your assignments.
Oh, then I can know what assignment I missed.
Right. I don't think you're missing anything, but I'll know for sure by the time I finish grading everything tomorrow. Okay. But please check with the other teachers, make sure you're all right at some point before Friday. We can still change things next week until Friday of next week, and then the progress reports go out.
How can I get progress report?
For the printed ones, I think you'll probably have to wait until we're back in session, but they'll probably email it through GridLink for your parents. Excuse me.